Here we can see the three-dimensional structure of a protein represented in sticks, with the nitrogen atoms coloured in blue, oxygen atoms red, sulfur atoms yellow, hydrogens white, and the carbons are coloured in green. We've chosen this particular protein because it contains many of the elements of protein structure that you need to know about in the A-level syllabus. This is a protein from a scorpion. It's part of the scorpion's venom, and it's a toxin which it uses to paralyze its prey. If you need to know more about this protein, you can find it in the protein data bank with the code 1PJV. Even though this is really a very small protein with only 32 amino acids, already you can see there's far too much detail in this image to really appreciate what's happening. So can we simplify this a great deal? Well, yes, we can hide all the amino acid side chains, all the R groups, and just concentrate on the shape of the protein backbone. So here we have those R groups deleted, and we can start to look at the protein secondary structure, the way that the amino acid backbone is folded up in local regions. You can see towards the top of the image there is a region that's helical, and towards the bottom two strands of extended protein where it looks rather stretched out, and then the second region that's stretched out running in parallel to it. These are the secondary structure elements of the protein. Firstly, there is the alpha helix. An alpha helix is stabilized by hydrogen bonds, a great many hydrogen bonds, between the amide proton and the carbonyl oxygen of an amino acid, 4 residues along the amino acid chain. Alpha helices are a very common element of protein secondary structure, and we often simplify their visualization by drawing them as a cartoon. You can see the cartoon there disappearing round the back while we go to look at the next element of protein secondary structure, the beta sheet. Beta sheets are again stabilized by a great many hydrogen bonds between carbonyl oxygens and amide hydrogens. But in contrast with the alpha helix, where these are 4 residues apart, in a beta sheet they may be very many residues apart, and they may even be in different protein molecules altogether. Again, we show beta sheets as cartoon representations, and here you can see that between each residue the conformation of the backbone zigzags, and this gives beta sheets the name beta pleated sheet, which you often see in the textbooks. The way the secondary structure elements of a protein come together forms the tertiary structure of the protein. And the tertiary structure is the arrangement of those secondary structure elements as they fold together to form the compact shape of the protein. There's another element of protein structure we haven't yet talked about, and it's not present in all proteins, but it is in this particular one, and that's the presence of disulfide or SS bonds. Here we can see this protein has 3 of them, and they're formed as the reaction between the sulfur groups at the end of cysteine amino acid side chains covalently bind together to form a link between the 2 sulfurs, hence disulfide bond. Disulfide bond is a covalent bond, and it's very strong and therefore pins the tertiary structure of the protein together and makes it very stable. Disulfide bonds are often found in proteins which are secreted from the cell into the environment, such as this protein from a scorpion, where it has to inject this venom into its prey.